All right, Josh, can you see everything?
Yeah.
Okay. Splendid. So it reads, there's a 30-mile-per-hour wind on a 130-degree bearing. A pilot wishes to travel exactly 500 miles per hour on a bearing of 120 degrees. What speed and bearing should the pilot set for the plane? So, again, we have the vector equation, right? But this time, what we're going to be doing is we're solving for, maybe we should call this wind, plane, and then result. This time we know what the result is, but we don't know the initial setting. So to find that, we'll just have to rearrange that vector equation a little bit. But that's the only difference here. So my resultant is 500 miles per hour at 120-degree bearing. So if I draw that 120-degree angle, we're down here, 90, and then 30 more makes 120 total. And then is 90, 90, 90, and then 60 more to make 330. And my wind vector, we know, is 30 miles per hour and 130 degrees. So if we do that, we're down here, so 90, 40. So our angle of rotation is 90, 90, 90, and then 50 more. So our angle of rotation here is 320. So far, so good, Josh?
Yeah.
Okay. So I'm going to resolve this vector r into an x and y component. So the x component is going to be the magnitude times cosine of its angle of rotation. And its y component is going to be the magnitude times sine of its angle of rotation. Similarly, for the wind, I'm going to do the same thing. So my plane vector, x component, should be the difference of these instead of the sum, because we noted that relationship in the very beginning. Similarly, here, oops. So we'll just type that stuff into our calculator. Thought I opened that at the very beginning, but apparently it didn't want to do that. All right. Well, we're just being stubborn here, the emulator looks like, so I'm going to type this into my calculator in my hand that you can't see. I hope that's okay. So I have 410.03. I have about negative 230.72. So far, so good with that. Okay. So my speed,
Yeah, sorry.
that's okay. So my speed is just going to be basically Pythagorean theorem on those two components. So I type those two into my calculator. Again, my emulator wasn't showing up, so I'm just going to do this on my tabletop calculator. So 470.48 miles per hour. Bearing, I'm going to go ahead and plot the point 410, negative 230 somewhere. And if I'm looking for a bearing, looking for this angle, so I know that part is 90, and this part that's being drawn back to the x-axis is my phi. So my bearing is going to be just 90 plus phi, where phi is always tan inverse of, in this case, the absolute y component over the x component. So I type that in, and that part is about 29.37. So my bearing in totality is about 119.37. Does that feel okay there, Josh?
Yeah, I was just like, I didn't know which ones to subtract and stuff.
Yep. So I think it's usually, again, easiest before I start getting into any of the number stuff to just kind of think about the real life situation. So the wind is always going to act on the plane to create a result. We know the result, right? So we just had to rearrange that equation to get the plane part isolated. And if you got that far, it would have been, it's not so bad, right?
Yeah, thank you.
Of course. I'm going to stop the screen share now. So cosine, I'm going to first identify where cosine is positive, which happens in quadrants 1 and quadrants 4. Okay with that? Pi to 2 pi is quadrants 3 and quadrants 4. So the place that I'm looking for then is my angle to be in quadrant 4. So I'm looking for this angle, right? Okay. So the phi piece that I'm interested in is always the part that's drawn with respect to the x-axis. So the relationship between phi and that angle, theta, is going to be that theta is 2 pi minus phi. Right, because 2 pi is past phi, so I have to subtract phi from it to get back to where we want it. So whatever reason that's not opening, because it's being a duty head. So I'll go to my calculator. Since 0.52 is not a unit circle value, I have to go to my calculator to do that. So that is 5.26.
Is there any way you could do that, like once you find the quadrants, could you work on the unit circle and do that, or no?
Not unless that this value is like one of the coordinates on the unit circle.
Okay.
So if that was like 0.5 instead of 0.52, then yes, because a half is an x coordinate on the unit circle. So you could go and figure out where cosine has that value in that quadrant. But because it's not a unit circle value, you have to use the calculator to do that.
Thank you, that helps a lot.
Sure, I'm happy to help. Let me know if there's another one that you come across that you want to see done. Happy to take a break and help you out.